Alright, let's look at Prep Test 33, Game 3, which is from December 2000. This is a grouping game. It's an in and out grouping game. The reason for that is that they give us 10 variables, the joules in this case, and we are supposed to select 6 of them. Now, the thing about this game that stands out is that the variables that we're supposed to select from, the joules, are further divided into 3 subgroups. So there's rubies, sapphires, and topazes. The rubies are F, G, and H. There's 3 of them, 3 sapphires, J, K, and M, and 4 topazes, W, X, Y, and Z. So whenever we have an in and out game with subgroups or any kind of grouping game with subgroups, one of the things we definitely want to pay attention to right away is the kind of information LSAT gives us about how many we're going to be choosing from each subgroup. In this case, we know that we're choosing 6 overall, but we would like to know how many we're going to be choosing from each subgroup. And normally they do give us some kind of information like that, and then that information turns out to be very important in the game. So as we go through the rules, let's pay attention to that. And then I would recommend, whenever this situation comes up again, you do the same thing. As you go through the rules, you pay attention to any information they give you about how many you're going to be choosing from each subgroup. All right, so the rules. So the first rule says that at least 2 of the topazes are selected. I wrote it as we have a minimum of 2 topazes. So right away you notice that that is indeed information about how many we're supposed to select from a subgroup, in this case topazes. It's saying we have a minimum of 2. And that brings up a good point, which is that so far they have not told us, and indeed they're not going to tell us, that we need to select a ruby or a sapphire. If by the other rules we can do without one of those 2 categories, then we're allowed to, because so far they haven't said that, like you have to select at least 1 from each kind of stone or something like that, which is something they oftentimes say. But when they don't say it, we need to notice that, because that will be a key point in the game. Probably in this case it goes to the distribution. If we can select 3 topazes, then we would not have to select, if we're allowed to by all of the other rules, we could leave out entirely the rubies or the sapphires. We just need 6 total. So if we could get 3 topazes, then we could get 3 from the other group and leave 1 group out entirely. We do have to use a topaz though, because of this rule, which says a minimum of 2 topazes. All right. The next rule says if exactly 2 of the sapphires are selected, exactly 1 of the rubies is selected. So if exactly 2 sapphires, then exactly 1 ruby. Just one thing important to point out here is the exactly. You can't assume that, like, if you have 3 sapphires, then you have to have exactly 1 ruby. You have to hit the nail on the head here, otherwise this rule doesn't apply. Alright, next rule says if W is selected, then neither H nor Z is selected. So if W, then not H and not Z. That's pretty straightforward, and the last rule is definitely straightforward. It says if M is selected, W is also selected. So if M, then W. Alright, so we did get some pieces of information here and here about the subgroups and about how many are going to be coming from each subgroup. So that's actually going to be the key point of analysis in terms of the deductions. We can't really learn that much aside from what the distribution is going to look like. So let's think about the distribution. So probably the first thing that we want to think about when we look at the distributions is going to be the rule about topazes. We need at least 2 topazes. That's kind of the most specific information that we have about how many we're going to be selecting from each subgroup. So we need at least 2 topazes. So we could have 2 or we could have 3, and if we just consider this rule, we could have 4. But the problem with using all 4 topazes, many of you may have already figured it out, is that if we have W, then we have not H and not Z. And at this point we're worried about the if W then not Z, because W and Z are both topazes. So if we have one of them, we can't have the other one, which means we'll never be able to select all 4 topazes. So the maximum number of topazes that we'll be able to select is going to be 3. So the minimum of topazes is 2, and the maximum, because of this rule, W and Z can't be together, so the maximum is 3. So we're either going to have 2 or 3 topazes. All right, and that just kind of branches out. Like, I mean, we can almost draw it. Let's see here. We can have two topazes, or we can have three topazes. Okay, so let's see. And then let's think about what happens. We can think about the drawing further. We can say, like, all right, if we have two topazes, one sec. If we have two topazes, what else is going to have to happen? Well, if we have two topazes, then we know we're going to need 4 from the rubies and the sapphires. Okay, so they're gonna need to add up to 4. So when we're thinking about, we're examining this situation when we have two topazes. So we know that the rubies and the sapphires, then, because we need 6 total, the rubies and the sapphires are going to have to add up to 4. So when you first think about it, well, you're like, well, there's only 3 rubies and 3 sapphires. So I know that at the very least I'm going to have to use 1 from each group, because I wouldn't be able to get 4 from just one group. So you're okay. So then you're thinking, what kind of mix can I do? Well, let's say, can I go 3-1, like 3 rubies and 1 sapphire? That seems like it works. Can I do the reverse, 3 sapphires and 1 ruby? That also seems like it works. And then the next thing would be, can I do 2-2? Can I do 2 sapphires and 2 rubies at the same time? And the problem with that is this rule, right? I can't do 2 sapphires and 2 rubies, because if I have 2 sapphires, then I can only have 1 ruby, right? So you'll never be able to get 4 by taking 2 from each of the rubies and the sapphires, because the 2 sapphire condition does not allow for 2 rubies to be chosen. So hopefully that makes sense. So if we were drawing this further, and you wouldn't draw this on the test, obviously, but if we were drawing this further, we would say, okay, so we could choose 2 topazes, and then we could go with 3 rubies and 1 sapphire. Or we could go, the reverse. So 3 sapphires and 1 ruby. Okay? Okay, so we took care of what happens when we have 2 topazes over here, but what about when we have 3 topazes? So if we have 3 topazes, then we need 3 total from the rubies and sapphires. So one way we could do it is we could just go, well, we have 3 topazes, so we need 3, so let's take all 3 from the rubies. So we could go 3 rubies. Okay? And by the same token, we can go with 3 sapphires. Oh, sorry. By the same token, we can go with 3 sapphires. So we could do this. And that's a reasonable way to start that distribution, because it's the most uneven. It seems like the least complicated. You don't have to divide anything. You just go with 1 from either the rubies or the sapphire, or sorry, with 3 from either the rubies or the sapphires. But what else can we do? If we don't go with all 3 from either the rubies or the sapphires, then we'll divide them up between the rubies and the sapphires. So we need 3. So we could either go 2 from one and 1 from the other, right? And that will round out the amount of distributions that we can do here. So we can go 2 rubies and 1 sapphire, or, and I know this is getting a little bit crowded, but we can go with 2 sapphires and 1 ruby. Okay, so these would be the possibilities, and these would be all the possibilities. Let's just review them really quickly, since we're going through the exercise. I won't do this for every time we have a distribution like this. I won't go through in this much detail, but I think it's good to do it every now and then. So we started out with 2 topazes, and we were like, well, that would mean we need 4 from the rubies and the sapphires combined. And so we could go down this avenue where we're like 3 rubies and 1 sapphire. Or we can go 3 sapphires and 1 ruby. And that's it for 2 topazes. If we need 4 from the rubies and the sapphires, we can't split them evenly and go 2 rubies and 2 sapphires because of this rule. All right. So what happens if we go 3 topazes? Well, in this case, we have a little bit more flexibility. Because we don't need to use rubies or sapphires necessarily, we could leave them out entirely. Then if we have 3 topazes and we need 3 more, we could just fill it with 3 rubies, or we could fill it with 3 sapphires. right? But if we decide not to go with all rubies or all sapphires, and we decide to split it up, then we could split it up. It's going to have to add up to 3, so it's going to be 2 from one and 1 from the other. So it could be 2 rubies and 1 sapphire, or it could be 2 sapphires and 1 ruby. Okay? So this is the tree that represents what I put up here. These are basically different ways. When you take this and this, that's just a different way of expressing this fact. I think it's actually easier to see like this, but it's up to you. But this is how we will work it out. All right? Apart from the distribution, there's one other deduction I think that is worth making, which is this one here. It stems from this rule, which is this rule says if M then W, and then the rule above says if W then not H and not Z. So we have if M then W, and then if W then not H not Z, so we get this chain here. And from there, it seems like there are a few different ways it could go, and that will depend upon which distribution you end up in. Let's just think that out for 1 second a little more clearly. So we have if M, then we choose W, and Z is out. So, but you could still have 2 or 3 topazes, because you don't need, you could have WXY if you wanted to have 3 topazes, or you could just have 2. But the other thing is not H, and H is a ruby. So any solution in which we were saying we would have 3 rubies would not work. So this one over here would not work, and this one over here would not work. But the rest of the solutions would still work. The only thing is that we know we can't have the H. Okay? And that would be it. So from here, I would pretty much go into the questions. You have a lot of information about the distribution, not so much about like who has to be chosen or can't be chosen. A lot of that's going to be contingent upon the question they ask you. And I'll do the questions in the next video, and I hope to get through all of them. So I'll see you in that video. But actually, if you had trouble with this game and you messed up some of the questions, you might want to just try the questions yourself now, because hopefully the setup will have clarified a lot of the issues you have, and you'll be able to answer the questions now without too much problem. But I will do them in the next video.